Good morning, everyone. Thank you so much for joining us here at the first annual ZIP Technologies and Transit Operations Conference, proudly hosted by the Canadian Urban Transit Research and Innovation Consortium, CUTRIC, here on this digital platform. My name is Parvati Pillai, and I work as a program manager for ZIP Consulting Services and Business Development at CUTRIC. We have an interesting panel lined up here today with a knowledgeable panelists who would be sharing their insights on the topic that we have today. But before we begin, we would start off with a word from our sponsor, and I would like to welcome Nicholas Foucault, Vice President, Marketing and Strategic Partnerships at Ballard Power Systems, to say a few words. Over to you, Nicholas, for the sponsor.
Bonjour, good morning, Parvati. Very delighted to be sponsoring the session dedicated to hydrogen and fuel cell technology. But moreover, I'm very proud to be representing today the 900 people of Ballard Power Systems, which are dedicated to advance clean mobility. For the past 40 years, we have been developing fuel cell technology, and which we strongly believe will have a key role to play in the future of our planet, to enable a decarbonization and energy transition. So we started our journey, as I mentioned, 40 years ago, and back in the late 90s, we put the first ever zero emission bus on the road in Vancouver, powered by fuel cell technology. So today, it's really very important for us to be part of that dialogue and discussion organized by CUTRIC around zero emission buses, and we are very pleased to be sponsoring that session. Thank you very much.
Bonjour, hello. My name is Nicholas Foucault. I'm the Vice President of Marketing and Strategic Partnership for Ballard Power Systems. We are thrilled to be sponsoring and participating to the Zero Emission Bus Conference. Now, with the strong support of the federal government, it is time to deploy zero emission buses at scale.
Thank you so much to Ballard Power Systems, our platinum sponsor, making this conference, this particular session a reality. Thank you to Ballard and Nicholas. So why don't we start with the presentation here, but before we dive into the panelists presenting their insights, I do want to set the context here a little bit. Hydrogen, as we all know, is a very viable solution to electrify, and Canadian manufacturers are leading the game all across the world. Still in Canada, we are somewhere stuck in the nostalgia technology of the 2010 Whistler trial. Although technological evolution has taken us to newer heights already, what are those options that the new technology present here? We are talking about newest innovations in hydrogen fuel cell electric buses and fueling technologies, and I do have the privilege of welcoming the experts in the manufacturing sector to this particular panel, Mr. CUTRIC Burkhardt, Vice President, Engineering Services, New Flyer and MCI. Welcome, Kurt. I do have Mr. Rob Harvey, Director, Energy Infrastructure, Fuel Cell and Hydrogen Technologies at Cummins Incorporated. Thank you so much, Rob, for joining us here. We have Nicholas Pockard, Vice President and Marketing and Strategic Partnerships at Ballard. Welcome again, Nicholas. And we have Mr. Colin Armstrong, CEO at HTech. Thank you so much to all our dear panelists for joining this particular session. I'm looking forward to a very exciting session with the Q&A coming from our audience already. But before we do, I do want to open the floor to each of you to have a brief presentation to set the stage. So why don't you start with a presentation here, Kirk? Over to you.
Okay, thank you very much. Hello and welcome. It's very nice to be here. Thank you again. My name is Kirk Burkhardt. I'm the Vice President of Engineering Services at New Flyer and MCI. And first of all, I'd like to thank CUTRIC, the entire team, for organizing another great session for us all. I've always enjoyed participating in these, and I'm very much looking forward to this panel discussion. And more than ever, I'm always pleased to speak about our hydrogen fuel cell electric buses, and looking forward to the discussion on industry trends. Next slide, please. Our journey at New Flyer began in 1993 with prototype technology, followed by a 20-bus evaluation program for the 2010 Olympics, which helped lead to our current generation platform known as the xcelsior Charge H2. In 2018, we delivered the first 60-foot zero-emission fuel cell bus in North America. And today, our fuel cell buses using Ballard fuel cells have been deployed with some of the most notable zero-emission leaders, including Sunline, Orange County, AC Transit, and Champaign-Urbana. Over the past few years, we've watched the zero-emission bus market grow to approximately 35% of the total bus purchases planned. And in fact, next year, approximately 10% of our zero-emission bus deliveries will be actually fuel cell electric. Next slide, please. We have and will continue to support this growth with both education and the necessary tools to be successful. That's why we built the Vehicle Innovation Center, dedicated to advancing technology and providing critical workforce development to an industry facing significant technological change. Second, any zero-emission operation will benefit from data and analytics to better understand their zero-emission fleet and duty cycles. Thus, we include New Flyer Connect telematics on every electric bus we build to harness data for better decisions and optimized management of any ZEV fleet. Of course, further growth could be enabled by more funding and a more economical and accessible hydrogen supply, which I'm sure we'll discuss today. Regardless, interest in hydrogen as a viable option continues to gain momentum. We believe this from the start, and we knew there would be growing interest in fuel cell technology. We're not surprised. Therefore, it only made sense for us to offer both electric vehicles. This interest is attributed to a couple of factors. One that seems obvious, of course, would be EV range and battery capacity are still less than desired. Therefore, extending the vehicle's range with a fuel cell only made sense. The xcelsior Charge H2 is a battery electric bus, but it uses hydrogen, a hydrogen fuel cell, to charge the battery, thereby extending the range of the vehicle. We actually refer to it as a range extender. This provides a more immediate one-to-one replacement for conventional propulsion with faster refueling time and less infrastructure planning and complexity than for battery EVs. Leading to my second point, many agencies are becoming more educated and knowledgeable and realizing that scaling their depots and infrastructure for 100% electric is in some cases extremely difficult. They have learned quickly from the experience of others, and as a result, they have realized that the FCEB is a viable alternative when looking at the pros and cons. While there is certainly a capital cost premium today for the fuel cell electric vehicle and the hydrogen refueling infrastructure, agencies are now obtaining enough knowledge and data to project and compare the economics of both ZEVs at full scale to determine the best mix of zero-emission buses for their operation. Next slide, please. And one more, please. The xcelsior Charge H2 is the first 60-foot fuel cell electric bus to complete Altoona testing and establishes New Flyer as the only manufacturer to offer a mix of both 40-foot and 60-foot electric bus models that qualify for U.S. federal funding built on the proven Excelsior platform. Depending on the climate, topography, and the duty cycle, of course, we estimate a range of 300 to 350 miles for an XHE40 and an XHE60, as we refer to them respectively. In fact, we were able to achieve 350 miles on a hydrogen 40-foot bus in one of our demonstrations in the Southwest under severe conditions. Our engineers, next slide, please. Our engineers have drawn upon more than 50 years of experience with high voltage trolley and hybrid electric vehicles and over 20 years engineering fuel cell buses with our partners at Ballard to develop a unique approach to leveraging fuel cell electric technology. By ensuring that we have enough high voltage battery capacity to handle most vehicle performance needs, we do not use the fuel cell as the primary power for motion in most cases. Therefore, using the fuel cell as a battery charger while keeping it, for the most part, at steady state. Of course, the Xcelsior Charge H2 utilizes the same robust Siemens electric propulsion system as the Xcelsior Charge battery electric bus, leveraging technologies, leveraging parts, leveraging systems. It makes sense. It's good common sense. So in conclusion, hydrogen fuel cell electric technology offers solutions to challenges that other zero emissions technology may not. At New Flyer, we believe there is an appropriate use case for all three zero-emission technologies, and the selection is highly dependent on the infrastructure available, local energy costs, and the proposed duty cycles. We remain optimistic that with more education, data, and planning, we will continue to see the market for fuel cell electric buses grow, and I look forward to today's discussion. Thank you very much.
Thank you so much, Kirk, for that great presentation. Essentially, your points about how the fuel cell electric bus, the range extending capacities of that as a complementary EV can serve the needs of customers based on the specific duty cycles is a great point to take home. And I particularly appreciate the fact that you touched upon the importance of data-driven decision making when you decide how complementary solutions should be deployed. So thank you so much for that great presentation. I'm sure our audience will be having a lot of questions. Audience, please do raise your questions in the Q&A box. Thank you, Kirk. We would bring you back for the panel discussions. For now, we would like to actually welcome our next panelist, Mr. Rob Harvey, Director of Energy Infrastructure, Fuel Cell and Hydrogen Technologies at Cummins, to actually deliver your presentation. Over to you, Rob.
Transit Operations Conference. My talk today is going to be on moving from low carbon fueling stations to hydrogen hubs. Next slide, please. Just a little introduction to Cummins, our New Power business unit. We have a wide range of battery electric components and powertrains. We're in the battery electric bus business, supporting OEMs there. Fuel cell power modules and compositions, working with OEMs for bus, truck, and train manufacturers and fuel cell compositions. Hydrogen production and fueling, which is the focus of my comments today, with both industrial containerized and large-scale hydrogen production systems and fueling stations, and also stationary fuel cells for on-site microgrid and megawatt scale firming applications. Next slide, please. Let's move to the topic. When you look at the whole fueling space, there's been a lot of work, and it's not new. The excitement, certainly in the momentum, as we heard from Josipa and Minister McKenna, is certainly accelerating in Canada, and that's very exciting to see. But in terms of hydrogen fueling, in terms of building infrastructure, it's been going on for 10 or 15 years. And we've been involved in on-site fueling solutions for that time and have done about 60 stations in Europe and North America over that time. And we've seen an evolution. So the two endpoints, one is the on-site fueling stations, and the other end of the continuum is a hydrogen hub. This is the first public fueling station in Quebec. We partnered with and supported Harnois, the government of Quebec, Toyota, and Natural Resources Canada. And this is the station here. You can see the Esso station. At the top left, you can see this is a containerized high-stat 100 unit, which has got a capacity of about 200 kilograms per day. So you've got on-site generation of hydrogen. You've got the compression, storage, and dispensing. It's difficult to see, but in that middle row in the middle, you've got a hydrogen dispenser for vehicles right in line with the gasoline dispensers as well. And this is fairly typical for getting started. It's an on-site solution. It's sized right. You can put the electrolyzer turnkey system, as you see in the container, on site, and it's a good size solution for getting started. Now let's look at the other end of the spectrum. Is what you want to do is to have a hydrogen hub. And this is the Air Liquide project in Bécancour. This is our new Hylizer 1000, an indoor skidded solution, 5 megawatts, 2,000 kilogram a day capacity. This particular project has got 4 lines, 20 megawatts, 8,000 kilograms per day. It was commissioned in December, and we're very excited to be working with Air Liquide on this project. This is the largest PEM electrolyzer system in the world, producing green hydrogen for Air Liquide's hydrogen hub in Bécancour. And it's a hydrogen hub in its own right, because of the scale. But in Bécancour, there are a number of industrial companies that are producing hydrogen or using hydrogen, and Air Liquide is part of the hub. So it is probably, I think, the largest hydrogen hub in Canada. And the question is, how do we move from building individual fueling stations to hydrogen hubs as we build the infrastructure that's required for a massive increase in public transit, for buses, for hubs, for diesel fleets, and for commuter trains as well. Next slide. These are some of my thoughts on it, and I think I've spent a lot of time in this space, and I've seen a lot of successes. And I think I know, and working with the Urban Transit Task Force and the Canadian Fuel Cell Association, and also with CUTRIC, there's some observations and things that we're seeing. The first point is that a network solution is always more efficient and resilient than anyone going alone. And we've seen this in many systems, electricity grids, backup data storage, battery energy storage for microgrids. And I'll just point on one, data storage. The reason that we have a cloud and that all of us don't, keep our own backup storage is because it's more efficient. Because if we each had to buy our own backup storage and then have redundancy on the storage just in case it didn't work, we would be having a lot of capacity that we wouldn't use because we wouldn't use all of our storage. The advantage of the cloud and great data servers and storage is that they can allocate the amount of storage that I need and another company needs to what we actually use. And you've got a shared resource with the efficiencies of the network to spread across all the different users. You also have resiliency because you've got the ability to back up that network. The second point, but obviously we can't get there at once. We can't suddenly build a network and create it. The on-site generation may be the best solution for a small fleet demonstration, but the challenge is when you scale it, it's difficult to provide redundancy. So what happens if that station goes down and for mission critical fleets? The other observation is we're not starting from scratch. There's a hydrogen production and distribution system established by industrial gas companies that we're building on. We know that we have to dramatically increase the scale for 2030. It's going to involve multiple hydrogen sites. And there's a couple of developments, the virtual pipeline opportunities with larger scale capacity trailers and higher pressure trailers, and of course the liquid hydrogen fueling chain. And I think the key comment, the last comment, is to think beyond an individual fueling. We need scale in hydrogen production, and we need to be looking at providing other sites for other customers, even for on-site generation projects. We need to build the network organically, and as we each do our own projects, we will build that infrastructure that we need as an industry. Thank you.
Thank you so much, Rob. You highlighted the point about how we need to plan for the long term, and the hydrogen hubs is a great point to raise. So thank you so much. Dear audience, please do write your questions for Rob as well in the chat, in the Q&A box, I would like to welcome our next panelist, Mr. Nicholas Pockard, Vice President, Marketing and Strategic Partnerships at Ballard, for the next presentation. Over to you, Nicholas.
Thank you, Parvati. Let me just jump to the next slide. Thank you. So just maybe, even though we don't have too many fuel cell vehicle, especially transit buses on the road in Canada, but the deployment of those vehicles are accelerating worldwide. Today, there are over 3,500 transit buses and trucks and trains powered by Ballard technology in operation. And those vehicles have accumulated over 75 million kilometers on the road. So fuel cell technology works, is being used, is being deployed, and in many cities around the world today, you have passenger boarding fuel cell electric buses. So I think that's a very important point. But if you go to the next slide, I mentioned to you earlier that we started a journey at Ballard in the 1990s with the first fuel cell buses. And as you can see over the years, fuel cell electric buses have evolved. There was a very big difference from the first vehicle we put together in 1995 to even the 20 fuel cell buses which were deployed in Whistler in 2010 for the Olympics. At the time, you have to reinvent everything. There was no electric powertrain. Batteries couldn't be used in vehicle. And at the time, the first buses we made ourselves. In Whistler, the buses were done by integrator. Where we are today, manufacturers like New Flyer, and this is a bus here which is deployed on the right in California, are now building fuel cell electric bus as a part of their zero emission bus offering. And the technology around the fuel cell has evolved. Electric powertrain are much more mature and the cost has gone down and more reliable, and batteries can be used. So today, we are using both technology together. So battery, which I like to describe, I use Sprint Runner to provide all the acceleration and the very quick energy discharge that you need for the vehicle, and a fuel cell, which is a little bit your marathon runner, which is going to enable the bus to operate on long distance, but also provide that extra energy in order to heat the vehicle, so the vehicle can be truly zero emission on a hot summer day as well as on a winter day. Next slide. So if you look at where we are today, and this is, we are monitoring at Ballard over 100 buses every day, which are operating in the streets of cities in North America and Europe. So today, as we discussed, the range of the fuel cell bus is between 300 to 350 miles, above 500 kilometers. The consumption of the bus are getting better, more integrated, where the fuel consumption is probably less today than 8 kilograms per 100 kilometer. And what is very important also, as I mentioned, we are using hydrogen on fuel cell, not only to move the vehicle, but to keep the vehicle hot in a very cold winter day. Fuel cell are shown to be able to work over a long period of time. Fuel cell have lasted over 30,000 hours, which is 6-7 years without changing the fuel cell. And once at the end of life, we can refurbish a fuel cell. The cost of operation is going down, and fuel cell can operate from -40 to +50 degrees with no degradation. Fuel cell doesn't degrade based on the temperature. It generates heat, which also can be used to operate the vehicle. So it's very well adapted to Canadian very rigorous, challenging climate. Next slide. So, but what is the challenge we are facing in the future if you want to deploy more fuel cell electric buses? I think we need to continue to improve the total cost of ownership of fuel cell electric buses. And this is our mission at Ballard. We want to reduce the life cycle cost of the fuel cell power module. We have a program, internal program, which will lead to a cost reduction of the fuel cell stack, which is the heart of the fuel cell module, by 70% in the next 5 years. We are also working with our partners to improve reliability and durability of every component of a fuel cell engine, in order to reduce the maintenance cost and reduce the life cycle cost. We're introducing new series of components like oil-free air compressor, which can last for the entire lifetime of the vehicle. We are working with industrialization partners like Mahle in order to take the production of fuel cell buses from a few hundred to several thousand and tens of thousands on a fuel cell engine for buses and trucks. And what is important also, we are refurbishing our fuel cell system. Every year, we refurbish several thousand fuel cell systems where we reuse the plates which are used in the stack, and we recover and recycle up to 95% of the platinum and provide value back to the customers. We are working with our vehicle integrators like New Flyer in order to improve the efficiency of the vehicle, to better integrate the fuel cell with the hybrid powertrain, and the DC-DC and the thermal management system. And ultimately also we need with the ecosystem, with the industry, to lower the cost of hydrogen to be able to provide affordable, low carbon hydrogen to deliver this very attractive total cost of ownership for fuel cell electric buses. Thank you.
Thank you so much, Nicholas, for that great presentation, and particularly, hoping for a brighter future wherein, the price of the fuel cells, as you mentioned, are going to be decreasing, and it may follow the pattern that battery electric buses has had. It would become more and more economical for the customers. So really appreciate the customer-friendly approach that you're doing here from Ballard Power Systems. Thank you so much. Our audience would have a lot of questions for you, so stay tuned. And I would like to bring up our next panelist here, Mr. Colin Armstrong, CEO of HTech. Over to you for your presentation, Colin.
All right, thank you, Brady. Yeah, it's a pleasure to be here to talk about hydrogen. We've been a pretty passionate group at it, really what we call fueling the drive to hydrogen for about 15 years. So I thought I'd talk about a few of the things to help people understand the hydrogen supply chain and a few examples of what we've been up to and where we think the sector's going. Next slide, please. So in our business, and I think for a lot of people, it's really important to understand hydrogen and the various elements of it. It's really not just about the dispenser that the guys fueling the bus or people mostly see. There's quite the supply chain or value chain behind it. And in our world, we think of ourselves as the glue to keep it all together and make that turnkey solution. So just to backing up a little bit, if we understand what hydrogen enables, it's important on the way we think about the supply of it. So there's 4 key things. So the first one is really carbon management, or allowing the use of clean energy supplies, whether that's sequestration of natural gas, hydro, solar, other renewables. So that's the first element of it. The second is about distribution of the fuel. We need to move it to where it's needed. We need to supplement the electrical lines or the roadway or the train usage for distribution. And then this can be on a global scale with hydrogen as well. So that's a little bit beyond, I think, the scope of this discussion, but it's important to recognize that we can move low carbon energy around the globe quite effectively with hydrogen. And then really it allows the use of what we call a very efficient engine conversion system, which is the fuel cell that we've been talking about. And then as important as the carbon management is the zero emission tailpipe side of things. So when we think about hydrogen, we think about, okay, where do we get what energy are we distributing using it? So we have to produce it and package the hydrogen so we can move it to the place. In some cases, as Rob mentioned, is a very good proposition for using or making the hydrogen on site from electricity or even from natural gas. But a lot of time in our world, we're moving it on roads, so we're going to compress or liquefy it. And then there's the dispensing station side of things. And that's what obviously the public's going to see, or the users of the transit. And that becomes the standard dispenser. But there's a lot of elements to that over the years that we've been at this for almost 15 years. Excuse me, we put a lot of time and effort into really understanding how we bring the reliability up and the cost down, as really feeding into what Nicholas is talking about in total cost of ownership. Next slide. So just a real quick, from our perspective, what we're up to. So we operate under 2 platforms. One's technology solutions. And this is where we're really helping people package up their products, move them into market. We're providing design and engineering services. And really, this is about helping a lot of people start providing hydrogen fuel solutions and really driving that cost down by packaging things up, like is typical in the gasoline and diesel supply side of it. Next slide. So HTech and our other platform is what we call infrastructure. So this is where we are building, owning, and operating the assets. And we are involved in the 3 elements, which is the production/packaging, the distribution over the roadways, and then the fueling station dispensers. So we have a retail station in Vancouver that are providing it for the cars, the Mirai and the Nexo. And we're also providing heavy duty fueling infrastructure in Alberta. And in Quebec, we are working with Arnois and others like Hydrogenics or Cummins to provide firstly for the retail side of things, and then moving into the transit and heavy duty. So what we're really trying to do here is think about how we provide that level of service that the transit agencies need. And we need to, one customer, one transit agencies needs to be part of a hub, as been discussed. So the more applications, the more hydrogen supply, the more stations, the more service technicians, the more reliable and more cost effective the whole hub or whole solution is going to be for the likes of transit properties. Next slide, please. So just a couple of historic pictures here. So as I say, we've been involved in this quite a long time. We were pretty lucky to be involved in the Whistler Bus project. So some great challenges, some great successes there. It was in a mountain town. It was 7,542 kilometers from the source of the hydrogen. So we had to deal with all sorts of elements. The transit agency had to understand really the backup side of things. How much redundancy do we need? So this station was probably good for about 50 buses, even though there were 20 running. We also needed a whole week of hydrogen supply in case it had to be shipped from a different facility down in California. So a lot to be learned there. On the other project we were involved in was a mixture of hydrogen and natural gas. And I bring that up just because it was a good stepping stone, and we need to think of all different elements on how we get the transit properties to understand hydrogen on their properties. So we spent an awful lot of time on both of these with emergency response plans, training of technicians, getting them comfortable with it, understanding how we manage the hydrogen on site. So that's the on-site stuff. And as I talked about, we really have to think about the distribution and how we get the hydrogen to site, or if we make it on site, how we get the electricity to the electrolyzers. So
Thank you so much.
Looking forward to discussions and how we drive how we really drive the cost and the reliability and the availability of low carbon intensity hydrogen forward to the transit agency. Thank you so much.
Thank you so much, Colin, for painting the full picture of the production to distribution to dispensing story of hydrogen, and you set the stage for our panel discussions along with our other panelists. So we would be starting the Q&A session. We are very pleased to get a lot of questions from our audience who are very interested in asking a whole lot of questions. I don't know whether we would get through them all, but I do want to start with you, Rob, because you highlighted this hub and spoke model. So when an agency is listening to this presentation, you guys are the manufacturers, leaders in the space, and when an agency is looking to go to hydrogen, what do they need to do, or to go to a hub and spoke model? How do they determine whether they should go to a hub and spoke model wherein they share the hydrogen resource with other agencies, or should they be looking at a localized supply chain and constructing like an electrolyzer facility on site? What is that deciding point? You think we need to unmute you, Rob, there? Yeah,
I'll start that. I think the good news is the onus is not strictly on the transit agency to create the hub and spoke and everything else. They're in the business of providing safe and reliable service to their passengers. They want to move to zero emission platforms. And there are a lot of industry participants, some of them on this panel, that are quite invested and ready to help support the development of a fueling infrastructure, whether it's on site. I think with buses in particular, when you look at the volumes, it's more likely that delivered hydrogen and a smaller infrastructure on site will work better for bus transit agencies. I think the hub and spoke model is something that the onus is on the industry. And really what I'm saying is we all together have to have a view of building scale, both in hydrogen production and the ability to distribute hydrogen to fueling stations for different transit agencies. And over time, it's not, as each of these individual projects and transit agencies start with a zero emission fleet, we will build that infrastructure and get to where we need to get to.
So in your opinion, like from a supply chain perspective, and I would request Colin your insight here as well, who should control it? Like, who should be controlling the hydrogen supply? Should it be like the private sector, government, or both? Like, who should take charge here? Maybe Rob, you can add your insight, and then I will go to Colin.
I think there's an important role for government in the whole zero emission space, not just on supporting the initial fleet deployment of the buses themselves, but also on the infrastructure. I think the private sector is ready and willing to make investments in hydrogen production, and we're talking low carbon. So it could be green hydrogen from electrolysis, or blue hydrogen, which is natural gas plus carbon capture and sequestration. Both are good alternatives. But getting support for those transit agencies to sort of get those initial stations in place. So the government has a role, and I think the private sector is ready to make investments as well to get this started.
So thank you, Rob. Like, Colin, does this co-investment idea in terms of the hydrogen supply, is something that is you find appealing as well?
Yeah, absolutely. I think it has to be a collaborative approach here. So we need to sit down with the transit agencies, the government, and the suppliers like ourselves, and the equipment suppliers like Rob, and say, okay, what makes sense? What do people want to do? What scale do you want to start with, or what scale do you want to get to? How low carbon intensity do you want your hydrogen? Are you on a pathway to get there? So it's super important to be collaborative. I would say the industry players like ourselves, we're ready to sit down, and each area will be slightly different, but it's just a conversation, submitting RFIs and RFQs, and I think you'll have a pretty robust hydrogen supply for most locations in Canada, and it's just going to continue to improve. So it's really about that discussions, not just giving up because there were challenges in Whistler. There was lots and lots of learning from all that, from ask BC Transit all the stuff they learned on what they owned on the hydrogen supply versus the backup and the redundancy and all the different players. So yeah, I'd say it's a collaborative three-way discussion.
Mm-hmm. Great, because you highlighted this, lessons learned. I do want to ask our manufacturers who are on the line, and maybe I would start with you, Kurt, on the lessons learned from vehicle performance, from early deployments, and when OEMs or manufacturers lead these deployments, what are the lessons that you have learned? Maybe if you can, highlight the lessons from the last 24 months, because as your presentations have shown, we have come a long way from where we were in 2010. It has been a decade of metamorphosis in the technology. But in terms of like OEM-led deployments, what have we learned in the past 24 months?
Yeah, absolutely. I mean, let me start by saying the technology is ready on the bus side. So we have learned much, because those early years, I must admit, were not easy years, but we had to take the challenge, and we had to do what we had to do. I think for us, the biggest lesson learned was, and I alluded to it in my opening, was balancing the fuel cell and the power output of the fuel cell with the battery capacity of the high voltage batteries, and not taxing the fuel cell as much as we did with the 2010 fleet for the BC Olympics, where most of what the vehicle needs can come from the battery, and getting the battery sized properly to keep the fuel cell for the most part at a steady state. I think the other significant lesson learned that we had was the scope of supply. So if the air intake to the fuel cell is critical and the coolant flow into the fuel cell is critical, I think it's very, that scope of supply for those items, for those control systems, has to be very carefully understood between the integrator, ourselves, such as New Flyer, and the innovator, such as Ballard, or even Hydrogenics or Cummins in this case. So understanding that scope of supply and what exactly is going to be integrated, I think we know very well now what that scope of supply needs to be, so that we've got very precise control of air and coolant into the fuel cell to maximize its performance and maximize its output. And then from there, I think those are the biggest two. And then I think picking your partners wisely and carefully to make sure that they've got a vision that's consistent with yours, and they've got, the R&D resources to put into the effort. Although I think we're past R&D at this point. So those would be, I guess, my three lessons learned from our programs of the past.
Thank you, Kirk. That is a great point in terms of the R&D dollars have already been put in, and you have learned the lesson. So I do want to turn to you, Nicholas, because one of the key considerations or a concern that transit agencies in Canada in particular would have when going to hydrogen fuel cell is how would it perform in extreme weather conditions. And fuel cells, people are unsure whether it would have an issue with extreme cold temperatures. But you did highlight the free start option and everything in your presentation. So I do want to turn to you. How has the technology evolved in terms of adapting to the real climatic conditions existing today in Canada to serve the interest of the customer?
Yes, it's a very good question. First of all, as I mentioned earlier, so fuel cell buses are in operation in very cold part of the world. We have had fuel cell buses in operation in Oslo, in the northern part of China, for many years. And so one of the key fundamentals is when the fuel cell runs, when it's in operation, fuel cell operates around 80 to 90 degrees. So fuel cell generate heat. So it can be minus 40 outside. Nothing is going to impact the operation of the fuel cell. It's, a power generator on its own. It generates a little bit of heat, which can be recovered to improve the efficiency of the bus. So during when the bus is on and during the entire day of operation, the temperature, the outside temperature is not going to impact the way a fuel cell operates, regardless if the bus operates on a really hot day in Palm Springs or in a really cold day in Winnipeg. So that's because of the nature of a fuel cell. Now, what you need to also to care about is how you're going to start your fuel cell if the bus has been cold and if the bus is have been stored overnight. So a lot of improvement has been done in the fuel cell technology in order to enable what you call a cold start, so to enable the fuel cell to start at low temperature, down to minus 25. So now this is done. We have ways of whenever we shut down the fuel cell to make sure the water gets out of the fuel cell. So when you start again or when it's stored at night, you don't have any water left in the fuel cell, so it cannot freeze. But inherently, when you look at how a fuel cell operates, how it is built, there's no impact on temperature like you have on batteries. And you all know that with the battery will not perform the same way on a hot day than on a cold day. And that's a fundamental difference that a fuel cell, because the way it operates and because it generates heat when it operates, can operate really in both hot and cold day with no change of the performance of the fuel cell. It will still give out the same amount of energy. And I think that's very important.
Mm-hmm. That's great to hear, because from the vehicle side, I believe the message is clear. The technology is ready to be operational at extreme weather conditions as the climate needs it. But I do want to turn to the providers of the hydrogen supply chain elements. So Rob, when it comes to supply chain, do you envision any kind of challenges posed by weather constraints, or do you hear anything from transit agency clients about weather impacting it, and are those fears baseless?
No, we don't. In fact, we have a joint venture with Enbridge for the Markham Energy Storage Facility for it's the largest electrolytic green hydrogen production plant in North America, and we've been operating since May of 2018. And obviously in cold weather and warm, and the reliability of the plant for operating in cold weather is not an issue. I think so. In terms of the Markham facility is, if you like, a very small hydrogen hub, or the start of the start one, and we could supply transit fleets with that hydrogen. I think when you look at it, so I don't look at an issue there, but what I think is important, and what I mentioned in my comments, is when you talk about a hydrogen hub and a network, you have to have resiliency as a network, and it's not just having backup supplies for delivering fuel for mission critical applications, and we're mindful of that in the discussions we're having as well. Thank you.
Mm-hmm. That's great to hear. So I do want to ask a question to you, Kurt, because you are from New Flyer, and New Flyer offers different platforms in terms of technology to the clients, and you do have CNG buses as well. So in terms of looking at CNG buses and comparing it with hydrogen fuel cell technology, and this hydrogen when it comes from natural gas, how do you see the environmental business case and the economic business case to map out? Because essentially essentially you are converting CNG to hydrogen to run your fuel cell electric buses. But essentially, your tailpipe emissions are zero. But are you paying justice to the fact that you are actually causing emissions in the the life cycle domain of things, wherein you can actually run a CNG bus on the other hand with a good efficiency? What is your take on that?
Well, I think right now CNG obviously just makes a lot more sense. I mean, it's just a lot more expensive to generate hydrogen, and you're right, some forms of hydrogen generation are greener than others. But we've got to explore all these methods, and we've got to advance the hydrogen supply and the hydrogen economy. So I think for right now, there's a place for CNG. There's a place for CNG across North America, and including even California, where it's very popular for obvious reasons, until the hydrogen supply and battery capacity and other zero emission technologies really take off. So I think, are there some improvements to be made in converting natural gas to hydrogen? Of course, there's advancements to be made. There's advancements needed. But for right now, offering CNG is a viable alternative. For us, we see it as a viable alternative for the next 5 or 10 years. We'll make that available. It's very easy to make that available because it's completely ready. It's easy for us to do it. So as long as there's a need, and we build buses to spec, so every transit agency is so unique. Somebody's going to need CNG. And in fact, what I think is the one to keep the eye on, what we're keeping a close eye on is, I've realized infrastructure is still an issue, fuel cell less so than battery electric, but we're keeping a very close eye on electric hybrids. Electric hybrids, in my mind, was a transitionary technology, not so much CNG, but maybe CNG now, but hybrids were for sure a transition technology. And when we go full electric, I think we're keeping a close eye on those hybrid volumes. And I don't think they're as attractive a solution as they once were, because electric is very real and fuel cell electric is very real. So I'd be thinking less about hybrid electrics, and I'd be thinking more about infrastructure, fuel cell electric, and battery electric. And CNG, I think CNG will coast where at the volumes it's at.
Great. Thank you so much, Kirk. That's a great point to end on because we are at time. I wish to thank you all for participating in this particular panel. It was great to listen to you. Great to hear where the technology has taken us from where we were a decade ago. And I am really, really looking forward to the advancements like, the leaders in the space like yourself are bringing. So thank you so much for participating in this particular session. And thank you for answering our audience questions as well. Thank you to dear audience for tuning into this particular session. We have several exciting sessions lined up today here at the first annual ZIP Technology and Transit Operations Conference, proudly hosted by CUTRIC. This is Parvati Pillai signing out. Thank you.